morning friends. Once again I welcome you to this lecture series soil mechanics, and in the last few lectures I devoted on shear strength and very preliminary information I have given, and also I have discussed about the different uh, test which you can carry out in the laboratory to find out the strength parameter of the soil, and they are basically shear, direct shear, triaxial and unconfined compression test. And the way we have discussed, we know that different soil will have different behavior, and whatever test I have discussed, they may be suitable for some case and very routine work we use them. But actually when we apply load to a additional load to a soil, and particularly when it is saturated, then pore pressure develops, and that pore pressure sometime it will dissipate over time, and some soil dissipation of pore pressure will be quicker like sand, and some soil its dissipation is very slow. So, as a result, shearing mechanism also will be different when we apply confining pressure and apply additional load to shear it, their mechanism also will be different. And in fact, in the field or in a real application, those are important, because particularly suppose the earthquake loading, it will apply it suddenly and it may not give enough time to dissipate. So, you have to sometime find out undrained condition before dissipation of pore pressure. We need to know the what is the shear strength. So, that is the way actually there are many other complexities. So, to address those things, we generally the triaxial test, as I have mentioned before, there is a very universal type of test, and we can simulate different types of field condition. So, this triaxial test itself we can classify into 3 different categories, and to address those are the points what I have highlighted just now. And these 3 categories namely are unconsolidated undrained test, and consolidated undrained test, and consolidated drain test. And what is the meaning of it? This is unconsolidated undrained test, that means whatever I have already mentioned under triaxial test, that we set a sample and then put a cell and then we force water to enter with some pressure, that is we by that we apply a confining pressure and then we apply axial load to shear that. So, that test generally takes around 15 minutes, and that is actually in this process we neither consolidate the sample nor we allow any dissipation of pore water by draining of water. So, that is called unconsolidated undrained test. UU test, universally it is known as UU test, UU test, unconsolidated undrained test, sometime it is called quick test. And next one is a consolidated undrained test, that is another test where when we apply the confining pressure and soil is saturated, then under that confining pressure, that pressure will before transferring to the soil grain, it goes to pore water inside it, and that in the form of pore water, excess pore water pressure. And if you allow some time and if you allow drainage, that slowly water will come out and this pore pressure will be dissipated, and slowly the applied confining pressure, whatever additional load you apply, that will be transferred to the soil grain. So, that is the stage, that is consolidation we do first, and then after consolidation the sample we can close the all drainage path, and then we can apply additional axial load then to shear the sample. So, that is called consolidated undrained test. Why it is called so? And this is universally known as CU. Why it is so? Because we first consolidate the sample and then we shear the sample in undrained condition. So, because of that it is called consolidated undrained test. And then third one is the consolidated drain test. This is also the same mechanism as it was in second case, that means first we consolidate the sample under a particular confining pressure, and then during shearing every application of additional axial load, whatever pore pressure develop, that has to be dissipated. That means, we have to shear it very slowly, so that when we apply the additional axial load, that because of that, if there is any pore pressure develop, that is obviously will develop, and that has to enough time has to be given to dissipate that pore pressure. So, that means, each test it will be 0 pore pressure time. So, has to be satisfied. So, this way if I first consolidate the sample, and again if we apply shear the sample by applying additional axial load, and by slowly but to dissipate the pore pressure in every increment, and so because of that this test actually take very long time, particularly for a very fine soil. Consolidation takes 1 or 2 days, and then again for shearing the complete sample it will take another 2-3 days, sometime week. Whereas, this consolidated undrained test, it takes for consolidation 1 day, and then shearing again, if it is undrained condition, then another maximum half an hour. And unconsolidated undrained test, it is just apply the confining pressure and then apply the additional axial load and then shear it. So, quickly it can be done. So, these are all different tests, some are very lengthy, some are very quick, but we cannot ignore because of this time taking, but in some situation when you require, that is the condition is prevailing in the field, then you have to follow that test condition. So, there are 3 by and large this triaxial test available. So, we can now discuss how we conduct the test, how we get the parameters. And you can see the first of all undrained test, undrained shear test, as already I have mentioned, this I have before. The simplest method to determine the values for the total strength parameter of soil is to subject suitable samples of the soil to this test. That means, under this test actually we can get the total stress parameter, because we are neither consolidating nor dissipating the pore pressure. In the test, the soil sample prevented from draining during shear and is therefore shear immediately after the application of the normal load in direct shear test. You apply normal load and then shear it immediately it happens. And in triaxial test, after confining pressure and additional axial load, that is also immediately it fails. The sample can be tested in 15 minutes, and there is no time for any pore pressure develop to dissipate. That means, whatever pore pressure develop in it, there is no time to dissipate that or distribute themselves evenly throughout the sample. So, whatever condition develop, that is the condition we generally share it, we do not bother what is happening inside, and so quickly we get some idea about the strength parameter by this test. Next is drain test. Before drain, actually I could have done undrained test also, either way it is the same way. Drain test means, this is not only drain test, it is actually consolidated drain test, consolidated drain test. That means, first stage soil has to be consolidated, and second stage while shearing one has to allow draining of water. That means, a particular soil is sample is there, and by inside the chamber it is applied confining pressure, and suppose the confining pressure is sigma 1, under that the soil is first consolidated and then axial load are applied. Suppose delta sigma 1 is applied, under that whatever pore pressure will be applied, pore pressure will develop, that has to be dissipated. So, you have to give some time, you have to see immediately after applying this additional axial load, what is the pore pressure developed, and you have to observe when the pore pressure becoming 0, then only you have to take the reading. So, that is the way we do this test. So, like that after this one is done, then delta sigma 2, we do delta sigma 3, like that we go on increasing, and finally, delta sigma f, that means at failure when how much delta additional axial load is required for reach the failure. So, that to be noted. So, this way actually we are getting totally draining condition and we get a very useful shear strength parameter. Porous disc is placed on the pedestal before the test sample is placed in position, so that water can drain out from soil. So, that is the confining pressure when we apply, and then because of the pore pressure inside. So, it will try to get dissipated. So, through porous stone it will come out. The shell pressure creates a pore water pressure within the soil sample, and the apparatus is left until the sample get consolidated. That means, until you have to monitor that because of this confining pressure, whatever pore pressure develop, it has to become close to 0. And there are number of checks, of course, pore pressure check. So, that I am not going right now, and this process usually takes about a day. So, consolidation process itself take 1 day, and then next stage will be your this is the way actually we do. We keep porous stone here, and through this water will be coming out when confining pressure will be there, and we will keep a burette and we will see the water mark will be changing, and after some time you will see there is no change. So, that indicates that pore pressure totally dissipated, and sometime other way it can be done. It could pore pressure dissipation can be from the top, it can be taken out, and this is kept. Sometimes if the soil is not properly saturated, sometimes water also can go through this and it can saturate it. So, that is the way also one can do the pore pressure check. That means, when it is get saturated and pore pressure is totally dissipated, that is the way one can do. And when the consolidation when consolidation is completed, sample is sheared by applying de Vito's stress. That is what I have already mentioned. At such a low rate, the strain that any pore water pressure induced in the sample have time to dissipate through the porous disc. That means, that bottom whatever porous disc is there. So, we have enough time, so that water goes out and pore pressure totally dissipates. And in this case, the pore water pressure is therefore always 0, and the effective stress are consequently equal to the applied stress. So, that means, it is effective stress, whatever finally we are getting, it is effective stress, and from this test whatever soil parameter we get, that is called effective stress parameter. And effective stress parameter, when it is total stress parameter, it is C u and phi u, and when it is effective stress that is C dash and phi dash. And when it is a consolidated undrained, so that is C dash or sometimes C D also it we call. So, that is the way. So, drain test C dash and phi dash. And consolidated undrained test, this is a test actually. The first stage, that means, your consolidation part after immediately after confining pressure, the soil has to be consolidated, and that consolidation after consolidation, the soil while shearing by additional axial load or pressure or de Vito's stress, that time actually drainage will be closed. Suppose in the previous case, each increment of additional axial load, we are observing that immediately after application of axial load, when there is a pore pressure developed, and that you have to give enough time to dissipate that pore pressure, and when it becomes 0, then we will go for next increment. Like that, you will be continuously apply de Vito's stress, and under each de Vito's stress we will see that pore pressure is 0. Like that, we will go up to failure, and at failure what is the de Vito's stress, that has to be observed or noted. So, that will give you that will help you to calculate the parameter. And whereas, in this consolidated undrained test, in these basically consolidation part is same, and then while draining, so the suppose this is the sample, sorry, suppose this is the sample and this is the chamber and this is resting on it, and whatever pore pressure arrangement was there, suppose here going out pore water pressure through it, and so when it is a consolidation taking place under application of confining pressure, drain is open, and during shear this because of the application of the deviator stress during shear, by applying additional axial stress or deviator stress during shear, this drain valve will be closed. So, that is why it is called consolidated undrained. That means, first stage we consolidate the sample, and in the second stage what we do, we do not allow drain, but what we do sometime. This way actually what way it is helpful. If I can conduct this way, then it takes 1 day for consolidation, and for shearing maybe another half an hour maximum. So, we can save the time, but what way it is useful? It is useful in the sense sometime during the shearing, when we apply additional axial load, immediately there is pore pressure development. So, we can keep some apparatus or some monitoring, so that we can measure the pore pressure at each load increment, and so finally, what we can do this from this test undrained condition we get another one set of data, and then subtracting pore pressure you can plot again another set of data, and that will give you another shear strength parameter, and this way actually by conducting this consolidated undrained test, we can get both undrained parameter and also drain parameter. How to get drain parameter? Whatever confining pressure or deviator stress or all we have applied, that we have to whatever, and then pore pressure measured, that observed pore pressure has to be subtracted to get the effective stress. So, when you plot the Mohr circle in terms of effective stress parameter, that way when that gives you the effective stress parameter. Suppose how it will be? Suppose based on total stress, we have got some circle like this, and we have got a tangent, and this gives you suppose based on total stress and without subtracting the pore pressure. And when you subtract from sigma 1, sigma 3, sigma 1, sigma 3 like that 1, 2, 3, 1, 2, 3, and 3 or 4 circle you have drawn, and you have drawn a common tangent, from there we get a C and we get value of 5. So, that gives you total stress. And suppose now there is a u. Now, if you subtract from sigma 1, sigma 1 minus u gives you sigma 1 dash. Similarly, sigma 3 minus u gives you sigma 3 dash. So, like that another set in terms of effective stress we can plot, and that gives you some another set of circle, and if you draw the tangent, and that tangent may become something like this. So, with that with the application I will show you later on. So, that means by using though the consolidated drain test is the most suitable test perhaps, mainly because we are actually giving enough time to dissipate the pore pressure, and that means total effective stress condition we are satisfying. Whereas, in drain test consolidated undrained test, we are consolidating same as the consolidated drain test, but during shear we are not allowing the drainage, but the result final outcome can be almost similar if you can observe or measure the pore pressure. and that pore pressure if I subtract from the total stress total pressure, then we will get the effective stress, set of effective stress. If you once you get, then you get another set of more circle, and from that you can draw the tangent, and by drawing the tangent we can get the value of C dash and phi dash. So, this is a very useful, that means, if I have the pore pressure measurement, the CU test can be almost come out as a CD test. And so, what way it is beneficial, because it is taking only very little time for shearing. So, most of the time people actually adopt this test instead of doing CD test, though we are not able to allow it draining and pore pressure making to 0, but still it is by this combination this test is very useful. So, now this way I will just keep one or two application whatever shear strength I have discussed, and let me take a first application. The first application is like this. You can see the following results were obtained from a series of undrained triaxial tests carried out undisturbed samples of a compacted soil, and we have applied different cell pressures about 200 and 400 and 600. When 400 cell pressure is applied, additional axial load was 342 Newton. So, generally we apply we measure load, and from the load we can calculate what is the stress that actually load by area, that I will show you. Again during the test, the because of the change of cross section, the area also will be changing, and that how much area is changing, that is a the formula already I have discussed, and by that actually you have to correct it area, you have to find out, and then find out the actual cross sectional area, and based on that we can find out the additional axial stress, and this is nothing but it is delta F actually force actually, and each sample originally 76 millimeter long and 30 millimeter in diameter experienced a vertical deformation of 5.1 millimeter. Draw the strength envelope and determine the Coulomb equation for the shear strength of the soil in terms of total stress. So, this is the problem, that means we have 3 tests. So, that means you can get 3 more circles, and you can draw the finally common tangent to all 3 circles, and which will be the more failure envelope, and that one we can find out the equation by knowing the value of C and phi. So, let me see that how to do it. So, this is the soil sample size is given, diameter is 38 millimeter and length is 76 millimeter. So, volume is pi d square by pi d square into L. So, this is the 86193 millimeter cube, and cross sectional area at failure will be suppose we have given a area cross sectional area at any time will be A naught by 1 minus epsilon. Okay. So, this is the this epsilon is nothing but longitudinal strain. Okay. So, now this longitudinal strain, if it is A naught, so we have got so this is nothing but it is if we express in terms of volume, so it is V by L minus delta L. So, this is another form, because area multiplied by L is the volume. So, you can write volume by 1 minus epsilon nothing but V by L minus delta L. So, we have got volume this much, and we have got your length is this, and change in length is this. So, we have got cross sectional area 1216 millimeter square, and then we have got deviator stress. That means, you have to find out deviator stress is nothing but delta sigma is the deviator stress, which is nothing but sigma 1 minus sigma 3. So, this deviator stress sometime we denote in different use different names. Sometime it is deviator stress, sometimes it is called principal stress difference, principal stress difference, sometime it is called additional axial stress, additional axial stress. So, these three name additional axial stress or deviator stress or principal stress difference. Principal stress difference, why? Because it is sigma 1 minus sigma 3, and additional axial stress because after confining pressure is acting all around same, and additionally you are giving axial. So, because of that it is called additional axial stress, and also it is deviator stress, that means from this to this. So, it is nothing but difference. So, that deviator stress. So, three name can be used to explain this. So, deviator stress is can be calculated this way. You can see if I go back to the data, it was actually 342 Newton. Okay. So, 340 Newton, this will be, this must be 0.3 and this is actually meter square. So, this will be 0.342. So, Newton, so it is actually ultimately expressed in kPa. This is expressed in kPa. So, Newton is expressed in kilonewton by dividing 1000, that means 0.342 become 0.342, and this is millimeter square. To make it meter square, it is multiplied by 10 to the power 6. So, it become 286 281 millimeter square. Similarly, whatever value was there, now 388 we can write, it is 0.388 into 10 to the power 6 divided by your 1216. This gives you 319. Similarly, if I see this one 465, this is actually 0.465 into 10 to the power 6 divided by 1216. This calculation gives you this 382. So, that means we have got now cell pressure and we have got deviator stress, and deviator stress, once you know sigma 1 minus sigma 3 equal to something about 281, then sigma 1 will be 281 plus sigma 3, and that gives you 481. So, 281 plus 481, similarly 31 and 400 719, 600 and 300 982. So, like that we get this versus this versus this and this versus this. That means, we are getting 200 481 one data, 400 and 719 and 600 982. So, we can draw 3 circle now. We can see in the next slide we could do 3 circle. First one 200 sigma 3 and this is the 381 481 something, then 400 and something the corresponding value, 600 sigma 3 corresponding your sigma 3 value, sigma 1 value. So, sigma 1 sigma 3 one set, sigma 1 sigma 3 second set, sigma 1 sigma 3 third set, and if you draw a tangent to this, you can see it is, you are getting a intercept, that is nothing but C u, and you are getting this phi, that is phi u. Since there is a no it is a undrained test, so we are getting C u. So, then shear strength equation, if I write Mohr Coulomb equation, tau equal to C u sigma tan phi u. So, 100 plus sigma tan 7 degrees, then that equation become 100 plus 0.123 sigma, that is kilonewton per meter square. This is the equation, shear strength equation for this test. So, this is one of the application, I just simple application I have done. I will do few more in the subsequent lecture. So, with this I will stop here. Thank you.